a Marshall amp that's taken out of a 2x12 cabinet that's got a fault. It's a JTM60 series, and this is one of the ones that had reverb in it. Normal reverb, boost reverb. A lot of them didn't have reverbs. This is a reverb one. The problem with this is this was in the 2x12 cabinet, which I've got taking it out. It kept cutting out at loud volume. It suddenly just cut out, and then the sound would come back on again quite quickly. Broken knob off. It sounded like an old amps from early days, which were designed rather crudely. You'd have a thing like that called a blocking capacitor, where the capacitor would charge it and wouldn't discharge, and then the valve would cut off, and then it'd come back on again. But I'm sure Marshall have done that a bit better with this. It's one of their attempts at updating with on these circuit boards with everything on, and connectors, all these connectors everywhere. Not what I like to see when I look inside a Marshall amp. I like to see point-to-point wiring and no extras at all, especially electronic components, ICs and transistors and boards. Anyway, before I was looking at it, and I noticed that the valves, which are stuck in down there, this one is pretty much melted. They seem to be cheap plastic holders, and that one doesn't look too good to me. And I thought, well, I'm not going to do anything else till I change that, because I'm not going to try and fix it, and then that packs up as well. It's a right pain to get out. There's hundreds of connectors, hundreds, and screws, and then you still can't get it out because it won't lift out because of these permanently soldered wires. I can't quite bend it out to get to it, so you have to. I've got to undersolder 3 wires, and I should just about get it out to get to that one there, and unsolder it. What I'm going to replace it with is this lovely ceramic gold contact one, which is circuit board mounted. Hope the others don't look melted. And that thing next to it, which is a bridge rectifier, I think looks like it's been pretty hot. Not sure. Anyway, everything else is just dusty. Nothing's swollen up or noticeably something wrong with it, but I'm going to change that. Valves. Well, I can test the valves. Not normally a valve. Who knows? I hope it's not something. There's some relays in here, reed relays in that. I hope it's not them. The reverb goes off on these 2 wires. It's in the cabinet. The reverb, transistors, horrible thing. Cover for the valves with a piece of foam rubber that pushes on top of the power valves, just to keep them in position so that they. I don't think they're ever going to work themselves loose. I took a photo. There were so many connectors and wires going everywhere, and now I've unplugged them. I'd never remember where they all went. So I took a photo, and hopefully all these connectors that have all come off, loads of them, loads and loads and loads. Look at them all. No wonder these things give trouble. I hope I remember where they all go. So, the JTM, and look at all these things on the back. The amps I like just have a speaker socket, and that's about it on the back. Oh well, it's modern. Replace the mounted socket, and the contacts inside are obviously pushed out the way by the melted plastic, which probably give a very bad contact. Had to take the board out, unsoldering wires as well to get to the socket there. While it's out, look at the board, make sure there's no track damage anywhere. There's the socket inside. The other ones are showing some sort of deformation as well, and I will just check the pins on them with a little pin tester I've got, just to make sure that they're tight before I put it back together with all these connectors, get them plugged in the right way round. This EL34 socket has had some sort of glue spill on it. It's like a super glue or something, and it's still sticky on the outside. It's gone. This has gone shiny. I don't know if it's run down into the connectors inside the socket. And this one's fine. Better check that the contacts are okay. Checking the sockets with this this pin socket tester, whether it grips or not. See, this one goes in nice, slide in. You can feel the grip of the little metal parts. This one, some of them, it's like, especially these ones, it's when it goes in, it's just stuck on the plastic. I'm not even sure it's making contact with the pins, and it jams in as well. That's not good at all. A couple are good, but these ones down here are really bad. They loosen up, keep going in and out, but it doesn't fit properly. I think this should, I mean, professionally I would replace this. I think it's just going to cause trouble. It's on big standoffs, so I'm not sure. I haven't got one. I have to look around, see if I can get one of them. Finally managed to get a new base for the power valve, 8-pin, with these extra long legs to replace this one, which has got some glue or something on it, and the pins are not gripping properly. You see, it's got long legs on them, so it's the right length to replace them. So I've just got to take that out and solder that in. Took quite a long time to come. The only place I could find this was in China. And there's the other one I've replaced that was all deformed out of shape. More of that glue that's got into this socket. Now I've taken the socket out. There's a lot of this glue that's run right through, and it's got into the pins and everything. I don't know what it is or where it came from. Put in the new socket. Make sure you put it in the right way round, because you can put it in the wrong way round if you're not careful. And you have to make sure you got it the right height as the other one, otherwise it's not going to screw into the top panel correctly. There's some of the hot melt glue that I got, whatever it is, run down. Do it manufacture? I don't know. It run into these sockets, and of course they can't run right through, so it's kind of filled up the socket with some glue. We look at the valve base. You probably can't see it, but on the valve base there is glue on the pins here. Glue on the pins, which would have caused really bad contacts. So I've got to clean those pins off. You have to remember to put this plastic circuit board guide retainer back in, as it tends to fall out. It's just held in a couple of little holes it presses into. While we're installing the circuit board, and of course remembering where all these loads and loads of connectors go, luckily I'd taken a photograph which helped me make sure that they go back in the right places. I noticed that a couple of these capacitors, these red ones, They're not soldered on properly. You can see it going up and down. It's either not been soldered on or has come loose. The others look okay. So that was not going to help with vibrations as well, so I'm just going to have to solder them. And I didn't notice any others, but that's quite critical, those capacitors not making contact. Testing the valves from the Marshall JTM60. There are 4 ECC83s in the amp marked Marshall ECC83. You have to set up the parameters and all the gauges, and you use the AVO book and you look up the one you want. ECC83 tells you how to set it, the voltage is supplied 250 volts, and how many milliamps to expect, and when you set the right setting, 1.6 on there and 2 volts negative on the grid. So we've done all that, so we can just test them now. And I'm just going to show you what the results should be. On this AVO tester, I've got a really good proper ECC83, what it should test. You set up the volts, 250 anodes, and you set the milliamps per volt and the grid voltage. And you can test on here any leakages between the heaters and the cathode and any other faults. And you can also measure the gain, the milliamps per volt. So, and you can test it for the anode 1 and anode 2, because there are 2 sections in the ECC83. So this is what a good one should look like. Turn on the heaters. We check the heater resistance, and down this end of the scale, that's like maximum resistance, no leakage at all, and that's what it should be. Just check the grid, that's fine. And then when you go to test, you turn this scale as it heats up. On the 2.5 milliamp scale, there's the line good, and it should be dead in the middle where it says 1, and it's spot on. And then you can that's for anode section 1, and you can change to anode section 2, and it's perfect match. Then what you do is you go back to the insulation test, because as the valve heats up sometimes you get leakage occurring. Insulation test there and there, dead right down the end, no movement at all. And that just checks the heaters working, and then we can turn off. Now that's a perfect valve. Now I'll just put in one of these and show you what's happening with these. If you're testing one of these Marshall valves, I've got it in there, just heater, check heater, seems alright now. Now I put it to test, let it heat up, and it's got a lot more gain than the specification for the ECC83. It's way over the top on anode 1, and anode 2 it's over anyway, but one of them's got a lot of gain. It's off the scale. Turn it down, it's really high, so it shouldn't be that, but a lot of gain is good as long as the rest of the valves are right. So we just check the heater insulation, and you can see the needles up, which means there's some leakage between the heater and the cathode, which will create noise and probably imbalance the circuit. It's not good, that should be way down. So that's you have to be careful where you put that. You wouldn't put it in the first stage gain, but as it's working quite well on gain, you could put it in the second stage, or towards the end, as it is working. But be careful with that heater insulation leakage. So that's that one. Testing another one of these Marshall valves. Got it in, anode 1. Let's just check the insulation. Well, that looks good. So we put it on test and see the milliamps per volt. It's just warming up. But this anode section 1, the gain very low. It's right down there, which says replace. And on anode 2, the second section's good, but the first section is poor, so you wouldn't want to use that anywhere because that actual one section of the valve's got poor amplification. Let's just check the insulation. The insulation was okay, but the gain on that section's no good. The third Marshall valve to test. Let's just check it out. Anode 1. Heater insulation is good at the moment. Let's just let it warm up and test the milliamps per volt on one section. It's come up okay, over what it should be, but pretty close. Let's just check the other section. That's good. So if this one's got no leakage, then we could put this right up at the first stage. Just check it now for leakage. No, that's good. Nothing. So that's a good one. And the fourth Marshall ECC83 for test. Don't seem to be any leakage problems, so let's just test the milliamps per volt. Section 1. It's creeping up, not quite as good as the others, but it's got into the green. And the other section is over, so it's not quite a balanced valve, but good enough to put this in near the front end, perhaps a second valve in. Check for the insulation. Low. So I think we can use 3 of those valves. One of them will have to be replaced, but make sure I put the one with the leakage in the last place where it's not going to be important. So I've marked the valves up with a felt tip pins. So we've got to replace one of these. Testing the 2 EL34s that came out the Marshall JTM. I don't know if these have been replaced in the past or not, because these are nice made in Russia ones. I've got yellow dots, which I'm assuming they're some sort of match pair, but I still need to test them. Now I've got the AVO valve tester here and the data book. And you look up in the data book here, EL34, and along here it tells you how to set the voltages, 250 volts, 250 volts, and how many milliamps to expect when the grid voltage is set to a certain value. Now the grid voltage, it says, should be set to 13.5, which it is on this scale here. And then we can measure the milliamps. When we set the milliamps per volt on here, it says set it to 11, I think it is. Yes, 11 on there, which is the scale. So I'm just going to put the valve in, or one of them in, and we'll test it. Got the valve to test plugged in over here. And all the settings correct, so we just check the heater's working. It is. Check the leakages between the cathode and the heater, make sure there's nothing wrong before we start putting the voltage on it. So that's test good, so we know we can put it to test, and it should be right in the middle of that green there, and it is, it's spot on. And I know these Sovtech valves made in Russia are normally excellent. I think they use the old Mullard equipment, so that's spot on. Just check the insulation again. Yeah, no leakages. So we've got one really good valve. I'll just test the other one. Takes a short time to heat up. Let's just check the heater. No problems with leakage. So put it on test. Just wait for it to heat up. It's glowing red at the moment. You probably can't see it. Oops. Just zoom in a bit more for you. Here comes the gain. It's coming up nicely. The other one was spot on, right in the middle. This one looks like it's the same. So yeah, a very nice matched pair. Perfect for what you want. Just recheck the insulation. No leakage. So, two good EL34s, and the only other valve, we've got to change one of the ECC83s, and I'll make sure I put them back in the right order. Testing the JTM60, I've put the valves back in, the two EL34s, and I've put the other four in the sequence which I think is best, depending on how I match them up, plus one new one. Now I haven't got the reverb connected up, which goes off here, but I can still test it. I've got a speaker under the bench, and initially I connected up to a variac on most equipment, so I can ramp the voltage up just to make sure everything's working properly, especially if I've had the circuit board out and disconnected lots of wires and things, just to make sure I've got it connected up correctly. So I'm going to turn the variac on. I can also, as I put the voltage up, I can measure the current, but we don't. This is a 60 watt JTM60, 60 watts. We don't want it really drawing more than about half an amp at 235 volts, which are what I'm aiming for. So I'm turning up the voltage on the variac. It's got a standby switch, but I always keep it on at all times. I don't like standby switches. I think it causes voltage surges on the components. Now this is a single input. It's also got a socket for a foot switch, which can be confusing if you're not careful. You plug the guitar into the foot switch rather than the input. So it's only a single socket, but it's got a switchable normal channel and then a boost channel, and that's what the foot switch is for. Or you've got a little switch you can press in here, and it changes the light from green to red. There's plenty of volumes, from a master volume down the end. There's bass, middle, treble on both channels. I'm going to just put the voltage up to 235 because it's working okay. A bit of buzzing picking up from the guitar, I think. It's that's on the normal green channel. Plug it into the red channel. Check the controls. That's got a gain control, which makes it really fuzzy, and its own volume control. Seems to be going loud enough. It's really a bit overdriven when you turn the gain up. And you've got the tone controls, which I can check out. Go back to the other channel. Yeah, the volume's working. The bass is working. Yeah, all the controls are working. Back to the boost. Seems to be working. When it first came, it was kept cutting out and it had hardly any volume. Now it's got loads of volume. So I've got to get it back into the cabinet, connect up the reverb, just make sure the reverb works. And I think we fixed the faults, which were basically the valve holders too, and a couple of capacitors weren't soldered incorrectly. Just got to put the valve protection cover, whatever you want to call it, goes back on, just slits in those slots, and there's 3 screws. I've just got these screwed in along the bottom here to cover that. Then we can put it back in the cabinet. Putting the amp back in the cabinet of the JTM60. The amp's just held in by some 6 screws on the top and one on the side. Look at the inside. I've taken the back panel off so you can see it's got 2 Heritage G12 8 ohms, and there is the rather small reverb tank. It's on a few rubber grommets, and the connections go underneath. I've just got some one left, one right. I've just got to work out which way round they go. A lot of dust inside. Also, these screws that hold the front on, sometimes they come loose. You need to just tighten them up. If you got this apart, you can also check the speaker ones just in case they're loose, which they are, so it's worth just checking those sort of things as well. Accutronics, made in USA, fairly small reverb tank. I forgot to check when I pulled these wires out which was the input, which was the output. Using this little mirror, I can see that one's marked in, and that one is marked out. So I can make sure I get them around the right way. Quick clean out of all the dust, might as well, with the hoover. Cleaned it all, brushed it down and cleaned it all out. Make it look a bit nicer. Finally, just testing this JTM60 after I've serviced it. One thing you should always do when you've got these FX send and return sockets on the back, if they don't get used for quite a long time, the contacts can sometimes get dirty and bad contacts and cause problems, because the sound inside normally goes through the contacts when they're not being used, in and out on these, and if you get dust and dirt, and generally they can go wrong. So you should always try and clean them up, make sure they're clean, because they can give problems. But one thing I found with this amp, if you link the FX loop, the one here, that is the series one, it's not neutral, so I put that in there, and let's just do the sounds now. A foot switch that can switch between the normal and the boosted section, and there's a reverb for the normal and boosted. I found that the reverb's weaker on normal, so I've got that on full, and the effects control here, although it doesn't have any effect when you've just got that link in there, so it doesn't matter where you set that. The reverb on the boost is much stronger, so I haven't got it set on full. The tone controls make a huge difference, especially on the boost, and it can get much too fuzzy if you have the gain set up too high, so I've got it quite down low. And there's the master volume, which is snapped off, so you can adjust that to suit. So let's just check out some of the sound. So with the green light on, which is just a normal channel, I I've just set it up. It's not too loud, just using the guitar straight in. There's a little bit of background hum with these amps, nothing to worry about really. So this is just, I've got the bass and middle down and the treble up, but so that's that channel. And then I've got about similar volume on the boosted channel, a little bit of gain, volume up, bass, a tiny bit of bass, maximum middle, and not much treble. It's very trebly, this boosted channel. Again, a bit of reverb. So it's a much thicker sound, but not too fuzzy if you don't turn this gain up too high. Plenty of drum punch and drive, and that's just on the green channel. Now on the slightly boosted channel. Much thicker sound, but I really like the punch that you get from the green channel. So that's the amp. I think it's a really nice sound now that's been serviced. Very, very punchy, bright, very bright. The boost channel, I think, goes a bit fuzzy. Let's see. Turn the gain up. This basic channel, I've got the volume on max. The bass. All the controls work very well, middle. Really brings out the tone, and a treble. All the controls work very well. the boosted channel. The gain's makes it very, very fuzzy. If you want that fuzzy sound. Much too distorted for my ears. Keep it lower. So that's the Marshall JTM fixed. I do think that putting that plug in the back makes an improvement to the sound. I'll just pull it out. And I don't think it's quite the same sound now. So all in all, quite a good amp once it's serviced. Good range of sounds, punchy, expressive. Considering it's got the horrible circuit board construction inside, they've done a good job. Now with the, let's just do it with the red channel, a tiny bit of gain, maximum volume, bass down, middle up, treble down, still got a little bit of reverb. So basically that's the two different sounds, the normal channel and the boosted channel. Good sounding amp, I think. Good range of sounds, nice and punchy, sounds good with the guitar without any effects at all. Bit of background buzz from the valve circuit, not much I can do about that. Besides that, seems like a good amp to be. Checking out the green channel. Max vol, minimum bass, bit of middle, maximum treble, pick up on straight from the guitar. Now we'll try it on the boosted channel, tiny bit of gain, max volume, bass a little bit, maximum treble, maximum middle, sorry, and trebles down. And by the way, the bit of reverb on the boosted one, there was maximum reverb on the normal channel. Seems to be better reverb on the boosted channel. That's the two different sounds, both really good, with a guitar without any effects at all. Very impressive.